like a good chunk of you guys have submitted the assignment, but to just quickly look at, well, two things. One, I put up the instructions for installing the packages that you need if you use the Windows subsystem either on your own computer or one of the school computers that's not in this room. Okay, if you use this on your own computer, there's going to be one minor change, which is right here where it says setup. That will be your username on your computer, not setup. That's what it is on the school computers. And then, right, okay, but otherwise everything else should be basically the same on your system. Okay, so, oh, the other thing would be that you may need to type sudo before this if you're doing it on your own computer, because, so I don't know why, but they configured these computers to have the Linux user as root, which is like the ultimate, that's the most powerful user you can be. That's usually a bad thing, so yours won't be root on your machine. Anyway, okay, so there's that, but then also, and I need to make a link to it, I've got a page where I'm putting all the terminal commands. Oh, and I never published it, whoops. Would be a bad thing. Terminal commands, right, so I just need to fill all these things in, so you know, how to copy, delete, remove, basically everything that you could probably ever need to do in the terminal, at least for now. So, yeah, okay, good? Yeah, so I know I threw a lot at you guys on Tuesday, and in particular, right, probably most of you have both A, never used Linux before, and B, never really had to use a terminal before. If memory serves. Is that pretty much correct? Yeah, well, you know, back in my day, that's all we had was a terminal. So, anyway. Okay, so let's get rid of this, and let's start talking some more C stuff. So, go into Genie, and we'll just, we'll start a new program, so, but let's actually go through this one first. So, to talk a few of the details here. So, unlike Python, C is really picky about data types. And so maybe let me put that a different way, that programming, you need to be picky about data types, and Python is just really loose about it, okay? So this, I think, is somewhat dangerous, because if you, for like most of you guys, Python was your first language, it sort of teaches you what we might consider to be bad programming habits, right? Because you're sort of sweeping details under the rug. Although it sort of is nice if you're first learning this programming language to not have to worry about some of the nitty-gritty like semicolons and data types and pointers and all of this stuff, right? Because it's a lot to keep up with in a first programming course. But anyway, I digress. So the stuff up at the top here, in most cases, we really only need one or maybe a couple of these sort of standard packages that are built into C, or at least for what we're going to be doing in the class. Basically what we're taking advantage of is certain things that are built into sort of the C standard library for doing, you know, data input, output, you know, maybe math if we need to do some math stuff. But for the most part, we really don't need a whole lot of header files. You can, of course, write your own for things. And then our program here is, well, everything has to be inside. Well, or sort of the main program, what runs is inside the main function, okay, no shock there. And functions in C, or any language for that matter, right, have some number of inputs and some number of outputs. And good morning, gentlemen, dirtbags. Some number of inputs and some number of outputs, and you have to declare what those things are. Okay, so in this particular case, the main function has no inputs, hence void, and an integer as an output. Now, this would work if we had put void here for the output. It's fine, but one of the sort of conventions, at least with Linux, is if your program does everything correctly and terminates correctly, it should return exit status 0 to the operating system, which says, yep, I finished, everything's cool. And so that's why we're returning an integer as opposed to nothing. And what you can use this for, of course, is in debugging if you've got a really big program and you've got some sort of like exception case and you want to know if you actually hit that exception case, you could have it return some other number to the OS, and then if the exit status wasn't 0, then you know that it hit a problem or something, okay? Yeah, so that's sort of the convention there. And then everything, of course, in C is in curly braces, right? Python, you only have to do indentation, which is, clean. But so the indentation actually doesn't matter in C, although it sure as heck makes it a lot easier to read if you do the curly braces, which you have to, but also indent things. Okay, so there's that. Again, unlike Python, pretty much every statement needs to be terminated with a semicolon. You will forget semicolons and curly braces probably more times than you care to count. Right? If I had a nickel for every time that I've forgotten one of those, wouldn't be teaching. So, right. Okay, now, this program uses, so what pieces of data, what data objects do we have just in this stupid little program? Yeah. Okay, we got a string. Okay, we have a string. We have an integer, and then, of course, we have sort of a nothing, right? So this thing here is called a string, and a string is really just a bunch of characters that are in memory all kind of in a row, and we'll kind of look later as to how these things actually land in memory. How are they encoded? So like if I were to actually go and find this in the memory, how did we say that this was encoded? In fact, we could see it here, right? In our listing file, this is the whole point of producing these things. How is hello world encoded? So this stuff here. Yeah, it's Ascii encoding, okay? So Ascii encoding, it's American Standard something, 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 right, that stands for something. Originally was a 7-bit per character scheme, and then it was relatively quickly extended to an 8-bit scheme. Okay, so let's actually just go to the old Google here, and actually, I want to say I have an Ascii chart in the files. If not, I meant to. Nope. Okay. I'll put one there because it's handy. All right, so you just can Google this, right? I mean, heck, there's AsciiTable.com, which is kind of ridiculous. But so here we go. Here's basically all 128 of the original Ascii characters. Now, a bunch of these are not characters in the sense that you wouldn't like print them, right? You can't spell words with them. But they were used for other things like information exchange, right? So if you had one computer talking to another, or a computer talking to a peripheral like a printer or something along those lines, you could have these 7-bit characters that would you could use to sort of control the communications and know whether or not the message was received successfully or whatever. Okay, so a bunch of these guys here at the beginning are what we call non-printing characters, right? They don't stand for anything like in the English language, but they're needed for data communication, basically. Okay, so there's 32 of those, and then starting with hexadecimal 20 are the printing characters, and basically that goes to the end. Okay, so space, exclamation, quote, hash mark, dollar sign, a bunch of the special symbols. Then you get the numbers, colon, semicolon, right, a bunch of things. And then you've got here the characters, the letters, right, A through Z in both capital and lowercase. And one thing to notice about the capital versus the lowercase, okay, this was pretty smart on their part, but what do you notice about them? So in hexadecimal, they're all 20 off of each other, right? So there's a fixed offset between the capitals and the lower cases, okay? What this means is if you want to write a function that converts lower to upper or vice versa, all you got to do is either add or subtract that appropriate offset amount, and it's easy. Okay, fortunately they're all in the same order, because wouldn't that have been annoying if they weren't in alphabetical order for some reason. Yeah, okay, so great. But what's the problem with that, with these 128 characters? I mean, what's the A in ASCII stand for? America. Okay, so this is great if you want to type American English, right? But what about the rest of the world? Forget them, right? Okay, and so pretty quickly was introduced extended ASCII, which uses the 8th bit, and that gets you another 128 characters, okay? And that allows you to get in some of the symbols for other European languages, like the accented vowels, that have acutes or circumflexes or whatever, or the C with the dangly bit from French, the cedilla, or the N with the tilde from Spanish, some of those sorts of things, and also currency symbols for, Britain, Japan. I'm not sure what that is. It's a little hard to see. And then, of course, you also get some of the mathematical symbols that you might need that aren't already the same as Latin characters. So you've got some of the Greek letters here, but not all of them, of course. Plus or minuses, infinities, things of that sort. And then sort of in the middle here, you've got a bunch of these sort of stupid-looking things, but if you put them together, you could use that to make, like, menus and like, put a box around your text and have it look good and stuff. So, old-school DOS programs back in the day, right, menus, borders and windows and stuff were kind of outlined in this set of characters. Okay, and these, so if we look back at our listing file, right, what is hello world? What's the first character here? The H, okay, which is 48 in hex, and if we look back at our table, 48 in hex is the capital H, okay? And then the rest of them are just, go through the list. And then the last thing, of course, is how is this thing terminated? So what's the last character in my string? It's the exclamation mark, okay, which is, if we look, hex 21 is the exclamation mark, okay, so that's good. But then there's one other byte here, okay, which is just 0, 0. This is how you know that you're at the end of a string. They're called null terminated, meaning that the end of it is just 0, 0. Okay, so the function that we passed this string to, or really we passed its memory address, but we'll get there, is going to keep printing characters until it runs into a 0, 0. And then it knows it's done. Okay? So in our case, because we just typed hello world, I never told the compiler to put the 0, 0 there at the end of the string, but it knows, hey, it's a string, it needs to be null terminated. Okay? So how much data does this hello world string take up? How many bytes? And there's two ways to answer that question. You can either count. How many is a hex? Okay, yeah, so 2 characters in hex is 1 byte. Or 8 bits, right? Yeah, so it should be 14. Okay, let's double check that we're not idiots here. Okay, how many do we have? 1, 2, 3, 4. So 4, 8, 12, 14. Okay, does that add up if we just count the letters? How many letters do we have? No, in the string, not the, language. Right, and it's 26. Oh, you meant the actual hex characters. Yeah, okay, got it. Exactly, the space counts, the comma counts, and the exclamation point at the end counts. Okay, what about the quote marks? Those are not part of the string. Okay, that's how in C you designate that you have a string. Now, if you want to have quotations in your string, then you have to do something, but you can do that. And because the quote is a valid ASCII character, yeah. So it's 14, okay, but that is counting, how many, if we just count the letters and stuff in this, how many do we have? We've got 5 from hello, the comma is 6, the space is 7, 5 more from that is 12, and then the exclamation mark is 13. So where's the 14th? It's the null terminator, right, which doesn't really look like it's part of the string, but it's got to be there. No. So, okay, good point. How do you know that the string has started? There's no special symbol for the start of a string, only the end of a string, okay? And it's up to you to know where the string starts by not being an idiot. It knows it because of a thing called pointers, which are memory addresses. So we know string starts at memory address something, okay? And so, in fact, when we get here, let me scroll down, and we'll talk about how this works later. Okay, this right here, right, in order to print something, we need to pass a piece of data to a function, right? And the put s, or put string, function works by, you basically tell it where in memory is the thing you want to output. Okay, the starting address. Okay, so if I were a bonehead and wanted to print only the last half of the string, I could just tell it where the memory for the W is. Okay, and it would start there and print characters until it hits the null terminator. Okay, so it's up to you to determine where the printing starts. The terminator tells it where to end. Okay. All right, so does that make sense? Yeah? Okay, good. So, I need my chair. All right, so let's go back to the, okay, so all of this is encoded in ASCII, okay? And let's see, we'll go here. So what about if you want to print numbers? Okay, so like what about if, let's say I want to make a, something like this. okay? And I want to print that. Okay, then what do I have to do? Well, probably I need this, okay? And then here's where it gets fun, okay? In C, if you want to print something other than a string, you need to use a special string in order to tell the printing function how this data is formatted. Basically, what kind of data are you printing, okay? This thing is called a format string, okay? And so what I'm going to do is, so for example, let's see, we need something like this, okay? And so, hold on, let me compile it and make sure I'm not being an idiot this morning. Let's see, where am I? Documents, CD examples, CD first day, hello. Okay, so we need to do GCC, hello.c. Oh, I forgot to save it. That would do it. Oh, there it is. Okay, the 4, right? And in fact, let me put in a \n, which basically tells it to do a carriage return so that it prints, it hits enter basically after it's done so that we can actually see it. Okay, so great, I just printed an integer. Now, if I go back up here, or go over my code, right, what is my format string in this case? %i \n, right? You'll get used to these eventually, but the \n basically just tells it, hit enter when you're done, right, so that it goes to a new line. And the %i here is really the money as to what kind of, how do we want to print this, okay? What type of data do I have here? It's an integer, okay? And so here I want to print it as an integer in base 10, okay? So let me pick a different number here, something a little bit more spicy, okay? 1832, right? Great. So the number there is 1832, but how is that actually going to be encoded in the computer? Like in memory someplace? Well, hex is really just shorthand for binary, right? But it's, so if I look in memory, am I going to see 1832 like I would with a string? No. What I would see is a bunch of this encoded in binary and or hex if we, shorthand it. Okay? And so to actually see what this is in hex, I'm going to change this to %x, okay? And then it's the same number, okay, but how did it get printed here? In hex, okay. So when I read that, is that 728? No, it's 728, okay? And how do we convert between that and hex, right? So 728 in hex means what? 8 plus 16 times 2 plus 16 squared times 7. Okay, and if we do that arithmetic, what should we get? We should get 1832, right? So we're just expressing it in base 16 here for hexadecimal. Okay, so you can print it, it's the same number, right? Same data. You can print it in either format, hex or decimal, and there's times where both are useful, okay? Particularly if we're printing memory addresses because those are always in hex, or we should always state them in hex. Okay, so, yeah, go ahead.
I have a question. You use %i sign for the integer.
Mm-hmm.
Is it possible to use also %d or does it string?
Yes, D for decimal, that's fine too. Yeah, so Farden's question is this. right? Same thing, okay? Right. Now, in terms of the encoding, so let's actually make the listing file again here with this new program, right? So what do I need to do this? So GCC, I want assembly, hello.c, output hello.s, okay? And then I want assembly, hello.s, output hello.o, and then I need to link it, so hello.o, oops, output hello, and then I need to do this to get my listing file, and then I'll remove a.out. Okay, so now if we go back to my listing file, reload. I think I screwed it up. There we go. Okay. Okay, so if we look what's going on here, we've got the format string also needs to get stored, okay? And if we looked at, oh, that's the listing. Sorry, wrong file. Dang it, what did I do? Okay, let's try this again. Oh, derp. Never told it to actually do it. There we go. There we are. Okay, so what do we have? Well, we've got our hello world string like before, okay? We've got our other string here for the format thing, okay? And what's all in it? The percent, the D, the backslash, and the N. And so the percent, the D, and then the backslash N got encoded here as 0A. And if we look at our Ascii table, what is 0A? New line. Okay, so that makes sense. And then, of course, we've got the zeros at the end to terminate it. Okay, now, the 1832 is actually right there. Okay, and let's see, 1 second. So there's two ways that numbers can get stored here. One is if I use a command basically to move an immediate number, it's not actually, that number is not stored in RAM anywhere. It's only stored inside the processor. And so you might look at this and say, wait a minute, Dr. McKinney, where is, I should see 728 somewhere in here. But if I look at that list of stuff, do I see 728 in there? Doesn't look like it. It's there, but it's not the way you think it is. Okay, we'll talk about that later. Okay, anyway. Right, okay, so let's go back to the C source here, right? So I can print numbers, and I can actually print lots of numbers if I want, right? So like, let's say, for example, right, something like this. I can print two things by basically just having the format string have two number things in it, okay? And then I just say, okay, well, what are my two things that I'm passing here, right? Number and number. And if we go back through, well, I'll just do the compiling, nothing special here. Dang it. Right, then it prints them. Okay, you notice how it put a space in between? Why did it put a space in between? Because I put a space in between in my format string, okay? Because I could also do something like this. So watch this. Let's print these in hex. And let's put a comma in between. Okay? It's convention, if you write something in hex, that what do you put at the front of it to sort of signify to the user that it's should be interpreted as hexadecimal instead? 0x, okay? And so if we look at my format string for just this little bit at the front that's visible, 0x %x, right? The 0x printed the 0x. And then the %x said, okay, I want you to put a number there in hex format. And what number was listed first? The one I called number, which was 1832, which, like we said, in hex was 728. Okay, so good, that's there. And then the other one's the other one, right? So you can format this stuff however you want. And here I've printed two numbers, but of course it's not necessary that they both be numbers in hex. I could print one in hex and one in decimal, or whatever I want, right? But how do I tell the computer to do that? By making the format string look however it needs to. Okay, good? Okay, so so far, none of the stuff that we've done here really is, I guess it's, we haven't really done any good programming. Okay, what I mean by that is, when you were programming in Python or Java or something, what do we not have in anything here? What are we missing? Well, what makes programming fun? Loops and conditionals, right? So how do we do conditional statements? And how do we do loops? Right, okay, so let's just take them in turn here, right? So let me just make some space here. All right, so let me print, let me just delete this, and let me just delete this. All right, so why don't we say, let's print something if number is bigger than second, and print something else if it's the other way, okay? All right, so how would I do this? In Python, how would I do it? Okay, so what's the condition here that I want to check? If number is, let's say, less than second, okay, what do I want to do? Okay, I can print something. Okay. And what do I want to do in the other case? Okay, so something like this, right?
Shouldn't it be number is bigger?
Like, that's, if the if statement is true, then that else statement is true also.
Well, okay, but number is less than second. What's the opposite of that? Oh, yes, I'm sorry. I meant to type number here. Thank you. This is why, see, I'm only about, 2 centimeters into the coffee, so. The old Roctagino. Right, okay, so good? Right. All right, so let's run this. Okay, number is smaller, and that makes sense, right? 1832 is less than 2021. Okay, great. So do I have to have an else statement here? No. I chose to in this case. Made sense, right? But I don't have to have the else statement. because maybe I only want to print if it's smaller and under no other circumstances. Yeah, okay. Yeah, it would just skip over it. So like, let's actually make that change. So I'm going to comment these lines out. Okay, and let's change the two numbers. Okay, so now what should happen? Nothing gets printed. Now, this condition is still evaluated, but because 5,000 is not less than 2021, the stuff inside this curly brace set gets skipped over, and it goes to whatever follows it in the program, which in this case is just nothing, right? So you don't have to have else statements. You know, sometimes you need them, sometimes you don't. And let's just make sure that that works. And it looked like nothing happened, right? Okay, good. All right, so conditionals are pretty easy. But what about if we wanted like some sort of really compound conditional? Like, for example, something like this. And I want to check, for example, to print if in the situation where number is less than second and number is less than third. Okay, if I run it like this, what's going to happen? Okay, so let's just look. Yeah, okay. So one of the things that's nice about Python, right, is how would you do a compound logical structure in Python? If you wanted to check if something's less than something and something, what do you put in between? You just put the word and, right? Isn't that nice? Because it's plain English? Yeah, well, we're not in Python anymore. So in C, oops, and Java for that matter, right? It's double ampersand is what you use for logical and, okay? And so now we can run that, and it compiles correctly. No. Yeah, basically, because Merca. Well, even though the guy who invented Python, I don't think is American, but yeah. Okay, so what about logical OR? Anybody happen to remember? Yep, it's two vertical lines. So this is the key that has the well, from your perspective, the backslash. Shift that gets you the vertical line, and two of those is logical OR. Okay, so now in this case, if I run this with the OR, why didn't anything print? Is 5,000 less than 2021? No, so this part of it is false. What about this part? Also false, and what's false or false? And false and false is also false, so that's why it didn't do anything, okay? But obviously if I change the numbers, then I can do this, right? It's good habit, I think, like in Python, you do this with, if you're going to build up a compound logical thing, use parentheses to kind of help you keep the structure from getting too complicated. But yeah, okay, good there. All right, so conditional's not too hard. There is one other example of sort of a compound conditional, the case switch format. This is really useful if you're programming like a menu, you know, press number, you know, press 1 for this game, press 2 for that game, press 3 for this game, and so on. You can use a case switch kind of thing for that. I was going to say, you guys are probably too young for ever this. Does anybody ever remember AOL Movie Phone? No. Okay, so before everybody had internet at their house and could just look up movie times by, you know, just Googling, there was a phone number that you would call. And then there'd be, a recording on the end of the line. It's like, to search for movie theaters, press 1. And he had like that ridiculous voice to go with it. But you do that, right? You go through this phone menu to find out, okay, I want to go to movies. I want to find out what time is this movie showing at different theaters in the area, or what movies are showing at that theater, and so on. And it'd be like, for Waterworld, press 1. For Terminator, press 2. And yeah, so if I were to program something like that, I would have used a case switch probably, output the audio, and then when the user hits a phone key, right, it makes a tone, then say, okay, well, which tone was it? And then, go to the appropriate submenu. Okay, so what about loops? Yeah, so let's do, say, a for loop, okay? Because we've got, what kind of loops do we have? For loops and while loops, and some languages also have do-while loops. What's the difference between a while loop and a do-while loop? Yeah, Owen. Yeah, so the difference is a while loop checks the condition of whether to enter the loop body before it does anything. A do-while loop automatically will run through the loop body once and then check whether it should continue looping. Okay? Right, okay, so let's write a for loop here. So what would be a nice for loop? Okay, what do we need to specify? Like in Python, what would I type for a for loop? For I in range something, okay? In C, I have to be a little bit more careful, okay? Okay, int I equals 0 or 1 or whatever I want to start counting with. I less than, let's say, 5, I'm just making this up, and then I++, okay? And so what do all the parts here mean, okay? So I've got 3 statements inside my parentheses to sort of set this up, and what are they? First off, I have to declare the name of my counting variable and its initial value, okay? And I just picked I, that's typical. And oftentimes we start with 0, right? No shock there. Okay, and what kind of thing am I looping over? In this case, an integer, right? It's a number, okay? And then what's the condition for continuing the loop? I want that thing to be less than 5. Okay, so when the integer hits, when I hits 5, what's going to happen? I'll stop looping. Okay, and then the last thing I have to specify is what happens to I each time I run, or the loop body runs. It adds 1 to it. Okay, so adding 1 to a variable is something you do so often in programming, right? That it's nice to have a shortcut for incrementing it. So I++ just means add 1 to I, and then it replaces I with that value, okay? You can also do minus minus to subtract 1, so we could count in the other order. That is sort of up to us, obviously, in which way we go through it. All right, so what do we want our loop body to do here? That's up to us. Yeah, okay, we could print I. All right, so we need a format string. And then the thing that we're printing. Okay, so let's run that. Okay, 0, 1, 2, 3, 4. And if I wanted to make it look a little nicer, let's put that in so that we can see it better. And then there it goes. Right? Yeah. Yeah, because the format string is getting reused each time I print. Okay. All right, so does it make sense why there's 5 of them even though we stopped at less than 5? right? Because we started counting at 0, not 1, right? And of course, you have to, use your head here with counting, right, to make sure you don't make an off by 1 error, okay? Okay, so that looks a bit like Python, so this is one of the things that I don't like, though, about Python, because if I wanted to do this in Python, what would I have done? Right, so let's just do this. All right, so for I in range, what? 0 to 5, 4, 5. Okay, this is why I hate Python. Oops. Oh, that's right, yeah. Well, I wanted it to carriage return. What? Oh, that's right. Okay, so this is one of the things I hate about Python, right? Because I stopped at 4, and so what did I put here? 5, okay? I just despise that. Now, that said, yes, and that's the nice thing, because in the C version, right, if I say I less than 5, how many things do I print? Well, it is 5, but it's only 5 because I started at 0, right? And so, I don't know, I think Python makes this a little bit more friendly. Okay, now here's one major difference between Python and C. It's still there, okay? Well, it does change, right? It makes sense that it changes, right? Because I is in the range 0 to 5, right? Each time the loop gets updated. So did I ever tell it to add 1 to I each time? Not explicitly, okay? But what's the default if you don't specify in Python? To add 1 each time. And if you want to do something else, then you have to specify that, okay? But this is a major difference between Python and C. So I am still in Python, right? And I still has the value 4, even though my program is done. Okay? That's not the case in C. So if I go over here and I do something like what's going to happen? Womp womp. Okay. Okay, so what's the issue here? Okay, what's the error say, first off? It's an undeclared thing. Okay, so what is this called if we're talking about whether a variable is or is not in context? What's the magic word for this? Scope, okay? I is not in scope anymore. It was a local variable, only existed within the loop function. Outside of the loop, it doesn't exist. Okay? This is nice because I again in another loop later on and not have to have like I1, I2, I3, and so on, right? That would get kind of annoying. Yeah, okay, so this is, but in Python, it's still there. It still has that value, which is, I don't know, maybe a little dangerous. But, yeah, okay. So there's loops. What else could we do with our loop here? So we wrote well here, let's get rid of our bad statement. So let's do a while loop as just sort of an example. All right. So what would be a good example of this? Oops. Okay, so I want to do, let's see, so percent %d \n number. Okay, so just making something up. While the number is less than, a billion or whatever, just keep multiplying it by itself and printing it until this statement is no longer true, in which case it'll dump out of our while loop. Okay, so nothing special. Oops. Oh, well, I guess it only happened once. Let me go pick a smaller number. What would happen if I put 1 there? Or 0 for that matter. Yep, we'd be here all day. So what did I mess up? Number. Okay, why did that happen? Hmm? No, it's not the for loop. Hold on, let me just make sure I actually recompiled that correctly. Okay, why is it going into an infinite loop? Because what's my number is 2, right? And I never modify the number, did I? Huh? Number times number. That is very weird. Okay, so we're getting an infinite loop here. Number is 2. Okay, am I being a complete idiot here, guys?
Is the reason 0 is still there? What? The return 0. Some number is to end the whole.
No, that won't do anything because we're getting stuck here. Well, okay, I don't think this is going to be an issue, but let me try. That's weird. All right, let me comment that out. Okay, that's weird. Huh?
Maybe it wasn't saved.
Oh, yeah, maybe that's it. Maybe I just forgot to save it. Yeah, you fool, you fell for one of the classic blunders. Whoops, okay, well, whatever. That was weird. All right, so what happens? Yeah, just keeps printing. Actually, okay, there is one other possibility here that we might have to worry about, which is what was the number that I typed that I was comparing to? It was big, okay, but I would have to be careful. What about if that number is bigger than, well, okay, what's the biggest integer that I can represent on a computer? That's maybe a little, that's a poorly formed question, but let's pick it apart. When I type int, how is that actually stored in memory? Well, it's all in binary, right? But how many bits? It depends, right? Okay, if I just type in int, it's going to be 32 bits. Okay, and if I want a 64-bit, I need to do a long int. Okay, 32 bits, what's the largest number that I can encode? Integer. It's like, what's the range of values here for integers? Okay, well, forget what the number is. Like, how would I figure out what it is? Where's my chalk? Okay, so we actually have there's two possibilities here, because signed or unsigned, can my ints be negative? They could, right? Now, in the particular numbers I picked here, none of them are negative, just for sake of demonstration, but could I have put -3 as one of my ints and everything would have been cool? Yes, okay, so if I have 32 bits worth of stuff to encode, what could I get? At the biggest end, well, if I got 32 bits and I've got pluses and minuses, I have to spend a bit basically on the plus or the minus. So how many bits do I really have? 31, okay? And so this is the range of values, okay? 2 to the 31, negative, all the way up through 2 to the 31, -1, because I have to spend, of course, an encoding on the number 0, right, which is sort of right there in the middle. All right, what is 2 to the 31st minus 1? It's a big number, but it's not that big. It's like 2-point-something billion. The 4 billion would be 2 to the 32nd, right? Yeah, it's like 2-point-whatever billion, right? This is the number that broke YouTube when the Gangnam Style video overflowed that. Right, whatever it is, okay. So 2-point-whatever-ish billion, who cares? So if I put in a number here that exceeds that, all right, so let's go here. All right, 10,000, so what did we say it was? 2-point-whatever billion? All right, so let's just be idiots. Oops, I don't have numlock on. Let's just be idiots and do 100,000, million, billion. Let's just be even more ridiculous here. All right, so I did. Well, let's just double check that. I know I saved it because it did something, right? Okay, so that actually was what was happening. It's too big in the sense that I'm mismatching my data types. Okay, what kind of integer is number in this case? What kind of piece of data is number? It's an integer, right? But how many bits? It was a 32-bit integer. Whereas that ridiculous number 999999999, can I express that as a 32-bit integer? No, I cannot. Okay, so how could I fix this? Well, let's go up here. Yeah, and let's make it a long int. Okay, that's going to break our loop here, but that's okay. Well, let's just make them all longs, and then we don't have to worry about it. Okay, and now, oh, that's interesting. Save, definitely saved. Well, that is really interesting, guys. No, all right. let me just, yeah, okay. I know that sounds ridiculous, but there's, no, that's not the problem then. No, it's not. Yeah, okay. Super mega. No. There's no such thing. Okay. So the long versus long or whatever, okay. What int meant on a computer has changed over time, okay? So back in the day, int meant 8-bit. And then it meant 16-bit. And then it meant 32, right? So long int, at one point, I think this is sort of Intel standard, right? So if we kind of go back, in the early 80s, all the computers out there were basically 8-bit machines, right? So your Commodores, your Apple II, those sorts of things. Okay, IBM PC comes out. It uses an Intel 8088 and is, depending on how you want to count, 8 or 16 bits, okay? But if you flash forward towards the late 80s, right, all the machines are at least 16-bit capable machines, okay? So int meant 16 bits. A long int, therefore, was 32 bits, and a long int was 64 bits, okay? Now, on more modern computers, int meant 32 bits because that's what right? So the tacking longs on here did make a difference, and it's not just me being flippant, okay? Yeah. So I'm actually not sure why that isn't working because the 9999 is,
Because I think you have to do number equals number plus 1. Because we have to increment the number.
but I'm not incrementing it though, I'm multiplying by itself, so it should still,
Which will stay in the same number. It is not incremented.
well, it's not incrementing, but it's replacing this value. Well, okay. Like I could do what I did before.
Could the actual number taken, like number taken in 2D?
Not if it's 64-bit, because it's gonna hit this limit before it hits the limit for what you can express in 64 bits.
Can you opposite where the printf comes first and the
No, that's not doing it. Okay. Well, you know what? Okay, hold on. Let's look at this and make sure that we're not bigger than. So if I did this with 64 bits, right? What's the biggest number I can encode in 64 bits? It'd be 2 to the 63 minus 1. Okay, what is 2 to the 63? 18th? All right, well, maybe I just have too many things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, we should still be good. Let me just chop off some of those. No? Oh, yeah, save. Okay, sorry. This is really interesting, gentlemen. Well, you guys have me stumped. Huh. Yeah. Well, think of it this way. Right now, you all have A's. Your grades just go down over time, right? Well, actually, right now, your grades are all undefined because...
I had a big issue with the math 112. Almost had a heart attack when I saw it.
Yeah, you had an F until suddenly you had an A, right, or whatever. Okay, well, there's probably somebody on the Twitch chat that's screaming at me right now for what I'm messing up here, but this is kind of interesting. So, yeah, okay, well, I'll figure that out, but if I just take, oh, I know, I'm an idiot. There's nothing wrong. It's the printing that we're messing up. What am I printing? I need to be printing a long, long int. Well, okay, maybe not, because I'm still in the loop, but, huh? Long, 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 long int. Well, I don't know. Let's just chop some zeros off of here. Or, this is really peculiar, guys. Oh, okay, I have an idea.
Can you try something?
What?
Can you move the printf above and the number below that?
Yes, I can do that. Up here?
Yeah, let me try that.
No. Well, let's find the magic number of 9s that we can have. Hey, okay. All right, so let's see what we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's strange. That's not what I would be expecting here. Yeah, okay. Well, anyway.
Initial number here? What's the initial number, like the value?
2. Right, and yeah, it's just 2, right? So when I removed that extra 9, right, so we get 2, 4, 16, 256, 65, 536, and so on, okay?
So one thing that will happen is because you're multiplying number by number, the number after 6 will be 236. When it multiplies,
Oh, it's going to be big, yes, but that's why I'm forcing 64-bit its here. Okay, actually, there is one possibility here.
that is big, but still not big enough to make
Okay, so because I can just read this, okay, that's kind of what I figured. It is correctly using the 64-bit registers, but I think the issue, and this is something we'll talk about, is there's an issue with basically how you load immediate numbers, and we'll talk about some of these details later. Yeah, so now this, for y'all's perspective, just looks like gobbledygook at this moment, right? And that's fine, we'll get there. But one of the things I wanted to check was that it was, in fact, correctly doing things as 64-bit hardware. And I know it is because it's using X's instead of W's. Okay, and we'll talk about that later. So, okay, so anyway, we got loops. Okay, yeah, there's some funny business, but basically we have loops, both of the for and the while variety. We've got conditional expressions, so if else, case switch you can look up, although I don't really think there's much reason for us to use it, at least for our purposes. We need to talk about next. We need to talk about functions. We've kind of talked a little bit about that because, of course, we've got the main function, right, which is sort of everything is subordinate. But if we want to write our own functions and pass parameters back and forth, how do we do that? Okay. And then also a big concept that we need to start talking about are pointers, which is basically where is this stuff in memory? Okay, and what's the difference between the value of a thing and the location of a thing. Then the other things we need to talk about is, and a string actually is an example of this, but okay, what is a string? It's just a sequence of things, right? Okay, so if I can have an integer, could I have an array of integers? Yes, okay. Or any other data type for that matter. Okay, so how do we do sort of slightly more compound data types like arrays of numbers or whatever, right? Okay, so that's kind of, I guess, on the docket for Tuesday. And I'll try and come up with a better explanation for what's going on here, but I have a few ideas. Okay. All right, questions, preguntas, fragens? Yes? Huh? In Klingon? Oh, I actually don't know the word for question in Klingon. Yeah, so. All right, well, I'll see you guys on Tuesday.